Hey guys, in the last lecture we saw some sums relating to the gamma distribution, chi-square distribution. We even saw one more distribution which is known as waiting time distribution. In this lecture, basically I'm going to start with a new distribution known as a beta distribution. Okay, going ahead, how do we denote beta distribution? X follows beta with parameter alpha and beta. It could be also written as x follows beta with parameter m comma n. Okay, so basically x is nothing but my random variable, alpha or my m is the first parameter of beta distribution. Okay, and beta comma n is second parameter of beta distribution. Okay, so what is this PDF? PDF, or I can say f of x, is nothing but 1 upon beta m comma n into x raised to m minus 1 into 1 minus x raised to n minus 1. What is the range of x? Basically, x lies between 0 to 1. These all would be given to us, right? So, there would be some function of CDF. We always calculated the CDF, right? But in this case, the proof of the CDF is not important. And you could view the CDF of a beta distribution on page number 13 of your tables book. So yeah, there is one property which would be used in the mean and the variance like the gamma distribution. So what is that property? The property is that integration from 0 to 1 x raised to 6 1 minus x raised to dx, right? This is the property, and what would be its answer? It would be nothing but beta of m comma n, right? And the value of this is nothing but gamma of n upon gamma of m plus n. This means nothing but this, right? This is the property basically. Like in the gamma distribution, I stated my gamma property. In this, I stated my beta property. So this property is known as beta property. This property, as used in the gamma distribution, were to find the mean and the variance. Similarly, even here, this property would be basically used to find mean and the variance of the beta distribution. So yeah, let's go ahead to find the mean or expectation of x, or I can say expectation, or I can say average. This means exactly the same. There is no difference between any of them. So what was the formula for expectation of x? It was nothing but x into f of x, right? Summed over all values of x. What is the values of x? It is nothing but 0 to 1. So let me just write 0 to 1. Okay. This is the formula for expectation of x. Going ahead, what was my next step? It was nothing but to substitute f of x. What is f of x? It is nothing but this 1 upon beta property of m and n, x raised to m minus 1, 1 minus x raised to n minus 1. Okay, so this is my property. As you all can see, this term does not have any variable of x. Since we are integrating with respect to x, this is termed as a constant and I can take it out here. So let me take it out. 1 upon beta m comma n, right? Integration of 0 to 1 x, I'm left with x into x raised to m minus 1, 1 minus x raised to n minus 1 dx. I can now club these two. How do I club these two? A raised to m into a raised to n is a raised to m plus n. So x raised to 1 plus m minus 1 would be nothing but x raised to m. So I can write this as nothing but x raised to m. Going ahead, let me compare this answer with my beta property. So what does my beta property states? This is my beta property. Control C, Control V. I'm comparing my beta property here. I want m and n. If you compare this term with respect to this term, this is exactly the same. So basically my n would be nothing but n only. If you compare this term and this term, I can write this term in this form as nothing but x raised to m plus 1 minus 1, right? Now I can compare these two and state that my m is nothing but m plus 1, right? So I got this. Now basically I can use the beta property. So instead of this, I can write my beta property. Okay. So what would be my answer? It would be 1 upon beta of m comma n into beta of, what is m here? M is nothing but m plus 1. So I'll write m plus 1 and n is exactly the same. So I will write n here. I get this. Let me write the answer as the form of gamma function, which is this function. So which would be nothing but, what is beta of m comma n? It is a straightforward formula I've been given. It is nothing but gamma of m, gamma of n upon gamma of m plus n, right? Into gamma of the first term, that is m, as you can see here, gamma of the first term, it would be nothing but m plus 1, since m is nothing but my m plus 1. So let me write that. M plus 1 into gamma of n remains the same. Similarly, even this term basically means this both term additional. So it would be nothing but gamma of m plus 1 plus n. Okay. So I can write this in a simplified form as nothing but gamma of m plus n upon gamma of m into gamma of n multiplied by gamma of m plus 1 into gamma of n upon gamma of m plus 1 plus n. Okay, so I can cut this. Okay, what is gamma of a? It is nothing but a minus 1 factorial. So let me write that in that format now. In the next step, I can write this as nothing but m plus n minus 1 factorial. Similarly, I can write this as m minus 1 factorial. I can write this as m factorial. Gamma of m plus 1, I can write this as m plus 1 minus 1 factorial, which is nothing but m factorial. And this would be m plus 1 plus n minus 1, which is nothing but m plus n factorial. Right? Now I can simplify. Let me write this as it is, the first term. Okay. I can write m factorial as nothing but m into m minus 1 factorial. What was my example? 5 factorial is nothing but 5 into 4 into 3 into 2 into 1, which is nothing but 5 into 4 factorial. I can say that n into n minus 1 factorial, right? When comparing it with n in generalized form. So I can even write this as m into m minus 1 factorial. Similarly, m plus n into m plus n minus 1 factorial. Now I can simplify this. This gets cancelled. This gets cancelled. I'm left with m upon m plus n. This is my expectation of x now, right? I use my beta property. Okay. So going ahead to find the variance. Similar way, even we will find the variance. How do you find the variance? It would be nothing but expectation of x square minus expectation of x the whole square, right? We have expectation of x, we just want expectation of x square. So let me write this. Expectation of x square is nothing but x square into f of x summed over all the values of x. So what is the range of x? It is 0 to 1, right? So let us move ahead. Let me substitute the value of fx. It would be nothing but this value, right? F of x, that is the PDF. So let me just copy paste it. Control C. What happened here? Control Z. Uh, Control C. Instead of f of x, I will write the value of f of x, which is nothing but this, right? Dx. Similar step, I would take this term constant. It does not contain the value of x, so it is a constant. I can take it out. So let me just take it out. I would be left with integration. No. 1 upon beta of m comma n. I would be left out integration from 0 to 1. X square x raised to m minus 1 1 minus x raised to n minus 1 dx, right? X raised to m minus 1 x square. What was the indices formula? A raised to m into a raised to n is nothing but a raised to m plus n, which is nothing but x raised to m minus 1 plus 2, right? M plus n, okay? It would be nothing but x raised to m plus 1. Minus 1 plus 2 is plus 1. So yeah. So now I can write this as x raised to m plus n. So writing in the next step, x raised to m plus 1, 1 minus x raised to n minus 1 dx. Now I can compare this with my beta property. Similar steps as expectation of x, guys. It is nothing different. Okay. So yeah, control C, control V, right? Now let me compare my answers. If you see this term and this term, these are exactly the same. So now I can say that my n is equal to n. So my n would be equal to n. Similarly, if I compare these two terms, this term and this term, it is not the same. So I have to write this term in the form of this term, right? So let me write it. It would be nothing but x raised to m plus 2 minus 1. Now it is in this term. If I compare these two, I get my m is nothing but m plus 2, right? Now I will write this equation. I'm so sorry. This equation in the form of this one, right? So let me just write that down. It would be nothing 1 upon beta of m comma n into what? Beta of m. M is nothing but my m plus 2, right? So beta of m plus 2 comma n remains same because it is n here and it is n here, so it remains the same. So it would be beta of m plus 2 comma n. Now writing this formula in the form of this formula, okay? So let me write that now. It would be nothing but, what is beta m comma n? It would be nothing but gamma of m, gamma of n upon gamma of m plus n. Same formula as this, nothing change. Now the change would be here. It would be gamma of m. What is m? M is nothing but my m plus 2 now. So let me write m plus 2. It would be gamma of m plus 2. Gamma of n is exactly the same. So there won't be any change. It would be gamma of n divided by gamma of m plus n, right? Here it is m plus 2 comma n, so it would be gamma of m plus 2 plus n, right? Now simplifying it, I can write this as nothing but gamma of m plus n upon gamma of m, gamma of n, right? I can write this as gamma of m plus 2 gamma of n upon gamma of m plus 2 plus n. Now I'm writing it in the form of factorial. So what is the formula for gamma of a? It would be a minus 1 factorial. So I can write the first term as nothing but m plus n minus 1 factorial, right? Divided by m minus 1 factorial, n minus 1 factorial. I can write m plus 2 as nothing but m plus 2 minus 1 factorial, which is nothing but m plus 1 factorial, right? And I can write this as n minus 1 factorial. Similarly, I can write this as m plus 2 plus n minus 1 factorial, which is nothing but m plus n plus 1 factorial, right? Simplifying it, this and this gets cancelled. Now, basically, the same logic which we applied above. I've used this logic several times, so now I'm not saying the logic, but leave it, I'm saying the logic. 5 into 4, 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. Similarly, it would be nothing but 5 into 4 factorial. Or I can say n into n minus 1 factorial when I compare 5 with n, right? So yeah, we'll do it in a similar manner. It would be nothing but this term remains as it is, m plus n minus 1 factorial upon m minus 1 factorial multiplied by m plus 1 is nothing but m plus 1 into m plus 1 minus 1 factorial, which is nothing but m factorial, right? Even the bottom side, it would be nothing but m plus n plus 1 into m plus n plus 1 minus 1 factorial. What was the formula? N into n minus 1 factorial. So I'm using this formula, okay guys? So it would be nothing but m plus n factorial, right? Now m factorial, I can write this as nothing but m into m minus 1 factorial. Similarly, I can write this now as nothing but m plus n into m plus n minus 1 factorial, right? Now simplifying it, this and this gets cancelled, this and this gets cancelled. So I am left with m plus 1 into m upon m plus n plus 1 into m plus n. Okay, I got my expectation of x squared. Now I'm finding variance. What was the formula for variance? So guys, now let's start with the variance aspect. What is the formula of variance? It is nothing but expectation of x square minus expectation of x the whole square, right? We have the formula of expectation of x square. Now we have even the formula for expectation of x. So I can now solve it. Okay, let's go ahead. Variance is equal to expectation of x square minus expectation of x the whole square. What is expectation of x square? It is nothing but m plus 1 into m upon m plus n plus 1 into m plus n. What is expectation of x? I found my expectation of x. It was nothing but m upon m plus n, right? So let me write that. M upon m plus n. Expectation of x the whole square. So m upon m plus n the whole square. Now basically what we'll be doing, it would be basic maths. We'll get our answer as mn upon m plus n the whole square m plus n plus 1. This we will get our answer. So if you want to try, you can try it on your own. It is quite manageable. So if you want to try, you can try it. But if you do not want to try, or you are not getting an answer after try, you can watch my lecture now. So it would be nothing but m square plus m. Denominator remains as it is. What did I do? I did multiply m with respect to each variable. So yeah, the denominator remains as it is. Similarly, this becomes m square upon m plus n the whole square, right? So now in order to make it common, to make the denominator common, what will I do? I can multiply this term by n plus n and this term by m plus n plus 1, right? So I get my answer as nothing but m square plus m into m plus n, right? Minus m square into m plus n plus 1 divided by a common denominator now. So what would be my common denominator? It would be m plus n plus 1 into m plus n the whole square. Now, yeah. So now I can simplify it. I will multiply m square with respect to each term, right? I'll get my value as nothing but m cube. M square into m is m cube. M square into n is m square n. Similarly, m into m is m square and m into n is nothing but mn. Okay, I'll multiply m square with each term. What will I get my answer? It would be nothing but m square into m is m cube. M square into n is m square n. M square into 1 is m square. Okay, it would be m plus n plus 1 m plus n the whole square. Now I can simplify. This and this gets cancelled. This and this gets cancelled. This and this gets cancelled. So I'm basically left with mn upon m plus n plus 1 m plus n the whole square. I got my variance, right? So yeah, I've done the proof for my variance aspect as well. Okay, so in the next lecture, we will be basically seeing the three type of normal distribution. We'll have that in deep. We'll calculate its probability and everything. So yeah, for now we are done with the beta part. In the next lecture, we start with the three parts of the normal distribution. Okay, thank you.